Okay, so let's start the session. In this session, we are going to look at the basics of Yarn, and then I'll walk you through how Apex is is claimed to be as a Yarn application. Um, so, just a minute. I think we are having some technical problem. Many people are not able to see my screen, so just I'll take a couple of minutes to fix it. Is the link? Can you click on this? Yeah. Okay.
Just check whether it's on. Can you see my screen?
Sorry, one more question for the audience. Are you able to see the screen?
I could see the screen.
Okay, cool. I think you people are able to see the screen. So let's start. In this session, we are going to see the basic introduction to Yarn, and then we will walk through how Apex is claimed to be a Yarn application. Okay, so what I'm going to do is I'll do a quick introduction to Apache Apex, because I assume many of you are attending our webinar for the first time, and our ultimate goal is we want to understand how Apex is a Yarn application. So just to introduce you to what Apex is, I'll spend a couple of minutes. I'll walk you through the Apache Apex. Then we will look into the basics of Yarn, and then we'll move to the next last topic, which is understanding Apex as a Yarn application. So what is Apache Apex? It's a stream processing platform. It runs on top of Hadoop, specifically Yarn. I have listed a few of the prominent features of Apex platform. One of the appealing thing is easy operability. What does it mean? It's really extremely easy to build your distributed applications on top of which will run on top of Hadoop using Apache Apex. Next thing is scalable. It is highly scalable. We support static as well as dynamic scalability. What does it mean? That before starting an application, you can configure the scalability factor using static scalability, or else you can go with dynamic scalability, where you can decide to scale out based on your input rate, or scaling, which is like shrink your application back based on the how much processing you want to do at the point in time. Performance wise, it's we have seen latency of single digit milliseconds in production. So I mean, it's really good performance, and it's almost near time processing. Fault tolerance, we take because it's a distributed systems, we normally face lots of issues with respect to what if one of the nodes goes down, or what if we have network issues. All those will be taken care by the platform, Apex platform, and that's hence we claim that we provide a fault tolerance processing for your applications. We have a malware library. This library contains lot many operators. So this operator term you are hearing for the first time. So what an operator is, it's just a code unit which you will need to develop your applications. So we have not many operators available in malware library, which are like commonly used components, which you can just plug in your applications and complete your applications within like a really small amount of time. And the last and most important point for this discussion today, we claim it's a Yarn native application, and we are going to see in the remaining part of this session why and how it is a Yarn native application. So this is the how architecture or technology stack for Apache Apex looks like. So at the very bottom, you see we have this physical layer where we actually have where you actually have your cluster. Your cluster can be physically deployed in your data like wherever you data centers or something, or you can actually have virtual machines and create your clusters, or we actually even support the clouds like EC2 or Amazon. So no matter where your infrastructure is, we support everything. On top of that, we actually certify our streaming platform on major Hadoop distros. To name few, we support Cloudera, Hortonworks, Pivotal, MapR, etc. And we actually can also run on vanilla Hadoop if you have just decided to install it on yourself. Then on top of Hadoop, where it comes our Apache Apex platform. This is a streaming processing engine which runs on top of Hadoop. And on top of our platform, you need to write the applications to fulfill your business needs. I have also mentioned Malla library here, which I explained a couple of minutes back. It's open source library where you have lot many operators which can be which satisfy commonly used use cases, and you can just use them as per your needs. There is one more layer on the top, which is graphical tools to design your applications and monitor your applications. These visual tools are provided by DataTorrent, and if you talk about management console, it is used to visualize the data, like visualize your applications on UI, and it comes as as part of community edition if you want to try Apache Apex. If not that, the next option you have is using you have data visualization dashboard where you can actually see the stats of your application, or you also have the graphical way of designing your applications. They are all part of DataTorrent RTS Community Edition. Sorry, the Enterprise Edition, not Community. But this Enterprise Edition is also available for free trial, and you can actually go ahead and explore all these options. And one more thing is we have REST APIs, which anyone you can integrate with your UI or any other tools you want, and actually fetch all the data which will be required for monitoring or any other activities. Now this is how our application visually looks like. It is actually a DAG, which stands for Director Acyclic Graph. So if we look at this diagram, the DAG nodes are actually the operators in Apex terminology, and the DAG edges are actually the streams in the Apex terminologies. What is an operator? So let's take a close look at these operators and streams. So operators are actually the processing units. These are the places where actual calculations or some data transformation will happen on the data. And streams are the units which connects operators. The data actually flow over the stream. And what is a tuple? A tuple is that is the atomic data we have. That is the smallest data unit which flows in the on the Apex platform. So these are I'm just introducing you to these basic terms like what is an operator, stream, what is a tuple, so you understand when we talk about the basics of Apex. Now I'm sure you are very excited to know how Apex is a Yarn application, or why do we claim it is a Yarn native application, and that is what we are going to see in upcoming slides. First, I'll introduce you to the Yarn. So Yarn actually stands for yet another. So actually, before starting on this, I would like to take a pause and know if anyone has any questions.
So actually, some people are asking about how that is it different from Spark and Storm.
Maybe Mohit would like to answer this question.
Yeah, so basically when we are looking at Spark and comparison of Spark with Apex, so there's a difference in terms of the way the approach is towards streaming. So Spark, as some of them might be knowing, is more on a micro batch kind of concept, if you look at the data frames, the RDD, the way it is designed, so it more is suited towards applications which are more kind of micro batch oriented applications. When it comes to Apex, it's the way we look at streaming. It's a true streaming engine where there is no concept of micro batching or taking data in batches as such. So it supports a real-time data processing, as well as the way we look at batch is like a subset of real-time data processing. So that's how it actually fits into. So what we'll do is we'll send out a link which kind of gives more details on the differences between Spark and Apex. Spark again has its own niche. It is utilized in the industry in a different manner, and Apex has its own niche. So I wouldn't really compare the two technologies, but if we look at true streaming, then Apex definitely is a true streaming platform.
Do we have any more questions?
No.
Okay, then I'll go ahead. YAN actually stands for Yet Another Resource Negotiator. YAN have whoever knows Hadoop, like Hadoop has started with a MapReduce framework, which was mainly batch processing. So YAN, the way it has been designed, it has made it very easy to write any kind of application, distributed applications or framework. And Apache Apex has taken advantage of that concept and had developed a framework on top of YAN. So let's do this quick comparison between Hadoop version 1 and version 2. This will help us understand how YAN is useful to us. So Hadoop version 1 was, as I just talked about it, it was about MapReduce, and in the backend, the infrastructure had major components called as job tracker and task tracker. So a job tracker uh, was a very important process in MapReduce version 1, where it had responsibility to schedule each and every application as well as each and every job related to all the applications. So it had a it used to play a very important role, and hence had a very high load and high responsibility, and was also a single point of failure. And whereas task tracker was the one which used to manage all the tasks on the single machine. So in Hadoop version 2, which is YARN, the responsibility of this job tracker have been split in multiple components. One is known as resource manager, which takes care of only all the resources in your cluster, as well as it helps in scheduling the application. And so it handles only application level. It doesn't go at the job level. Whereas the responsibility of running and maintaining the life cycle of each and every job, or we can call it as a task, is taken care by application master. And there is a timeline server just to keep track of all the logs and every activity in your cluster. Then task tracker is equal to node manager in Hadoop, where node manager actually takes care of again all the resources management of one machine. And in version 1, the processing slots we used to get used to be either map slots or reduce slots. So your processing was limited. You either can do a map processing or you can do a reduce processing. But in version 2, you just get a processing unit which is called as container. And how do you specify container is like you specify how much RAM or how much CPU processing power you need, and you will get this container where you can run like whatever process you want. So this flexibility provided by YARN has actually helped us to do a lot more than just MapReduce on top of Hadoop. As you can see, we can do a lot many different kind of programming using YARN. We can actually, beyond MapReduce, we can actually do graph programming, in-memory computing. You can write your search algos. You can actually write your streaming platforms or applications using YARN. So, and Apache Apex is actually one of the streaming apps.
So one question is again the comparison with Storm. So we have already sent an answer over the forum. Yeah, chat forum.
Okay. So this is how the architecture of Hadoop or Yarn looks like. So we have a major component which is resource manager. Resource manager takes care of all the resources of your cluster. It knows how much of processing power you have with respect to Yarn, how many CPU cores you have. So all that information is maintained, as well as it knows which all resources are in use right now and which are sitting idle to take care of your requests. Along with the resource management is also takes care of scheduling your applications. So when I ask my Hadoop to run particular application in the cluster, it will take care of scheduling or allocating resources to your application. The next component is node manager. A node manager actually sits on each and every node in your cluster, and it takes care of managing resources of that particular machine. And also it takes care of managing lifecycle of each and every container. In last slide, we just saw a container is just a logical unit which is allocated to a process. Um, so it can, node manager will handle lifecycle of that also. And the application master. Application master also runs inside a container, and it has all the responsibility with respect to application. What does that mean? So whenever you want to launch an application, App Master will decide or will know what all things need to be done to run an application, how many resources it needs, what kind of processes it needs to run, what kind of resources it needs. Everything is known to the App Master, and it takes care of uh, all the uh, all the management work. Like it will talk to resource manager to get the resources. It will communicate to node manager to tell it what to do. So all that load to run application is taken by application master. I'll move ahead and introduce you, like, this was the architecture. Now let's see what happens behind the scene when you actually try to run an application. So this is like physical distribution of your cluster will look like. Now let's see how it runs an application. So I assume I have a 3-node cluster. One of my node is a resource manager, and another 2 nodes are which runs node manager, which are just data nodes. They will just run your jobs. So I have this cluster and I want to run my application on top of that. So first thing you need to do is you need to submit your application to this cluster or to Hadoop. How do you do that? You will need some entity to talk to Hadoop to tell it to run your application. That entity is known as Yarn client. This is generally a Java code. So you need to write Java code to interact with the resource manager of Hadoop. So once you have Yarn client, it will start talking to the resource manager and it will ask it to submit to launch your application. So while submitting this request to launch an application, the information it needs to provide is details about application master. It doesn't need to give all the details about an application. It just need to give the details about app master. Then it needs to tell what all resources an app master will need, like how much CPU or memory it will need to run. And one more thing is, like, it need to tell like what it should do when app master container is launched. See, app master is again a custom code. App master is not given to you by Hadoop. Hadoop just launches an container for you where your app master process can run. But what to do in that process is all up to you. So Yarn client will have to give all this information to resource manager. Once the request comes to the resource manager, there is a component called applications manager inside resource manager, which will try to find some machine which can host your application master as per your specifications. Once it finds this machine, some such machine, it will launch the container to run your application master. When your application process boots up and starts running, it will register itself with the resource manager. Why it is required? Because resource manager should know where all your application masters are running, so that it can query for its status or health at any timing point. After this is done, application master takes the charge and it will then negotiate with the resource manager for required number of containers to fulfill the job. So let's say I need 2 containers to do a specific kind of processing. So application master will go to resource manager and ask for those 2 containers. When resource manager comes back with the required containers, they will be launched on the node managers. So let's say so when node manager actually spawns a container, application master tells it what all processes it needs to run inside those container, what kind of environment variables or configuration to use. All that will be taken care by application master. And when these containers are done, when they complete their job, the application master will shut down all the container and itself to conclude the working of this particular application. So any questions on this? Like this is like the basic workflow. Like any yarn job will run in this fashion. This is a basic like workflow which will happen. Um,
No questions as such.
okay. So I'll just go ahead.
Yeah.
Is there anything else?
So question is it like App Master would create multiple containers for a single application submission?
It practically yes, but I mean logically yes, but practically it doesn't create containers. It knows like it needs like for application it needs X number of containers. So it will ask those many containers from resource manager, and resource manager will actually create the containers. So the responsibility of application master is like request the containers and run the jobs inside the container. Then okay, I think there are no more questions, so I'll just go ahead. If we have any more, I'll just take it after uh, we go through a couple of slides. So this is a normal yarn application. Now I would like to introduce how Apex runs as a yarn application on top of Hadoop. So I'm taking again a cluster. This time my cluster is little bigger. I have 4 nodes, and I have one of them is resource manager, and 3 are just name the net data nodes. So and I'm just putting my yarn application we just saw here just for reference. So let's assume the application we just submitted in last slide is running in your cluster. One point I would like to highlight here, that for Apex to run, we don't need a new cluster or new setup. So let's say you already have a Hadoop setup running in your machine or in your organization. You can just use the same setup where your other jobs are already running, and your Apex jobs can coexist with your any other Hadoop jobs. So yeah, as we explained, the first thing we will need is a yarn client to talk to the resource manager. So what Apex provides you is a Apex CLI, which is a command line interface. This command line interface helps you to submit applications to the resource manager. It also helps you to do interaction with the application, like you want to change any configurations or you want to get any information of the application. That all you can manage using this command line interface. Also, you can stop or restart your applications using this command line interface. So all that, like you don't have to do any coding. Like ultimately, Yarn client has to be a Java code. So you don't have to do any coding. You can just use this command line directly to do any of processing you want. This Apex CLI has a component, Java component, which is Stram client. This Stram client is actually a wrapper over the Yarn client, and it will take care of all the it will actually provide all the features I just explained, and we will see more like details like what all things actually Yarn client do when it launches. The next thing for sure, like when you submit your job to the resource manager, is you are going to launch a app master on your cluster. So let's do it. So once I request the resource manager to launch my application, it has launched an application master for us. And now in Apex terminology, app master is actually a STRAM. STRAM stands for streaming application master. So I have just explained in last slide that app master is actually a Java code, custom Java code, and you have to write your app master depending on what kind of processing you want to do. So we have written this STRAM, considering all needs, all the things required to uh, write a streaming application. So this STRAM will see again in the next slides. I'm going to go through all the details of these new components I'm just introducing. So here I'm just showing you pictorially and introducing you these components. So this app master of Apex, which is STRAM, will be launched. What next? Yeah, this STRAM as a normal app master will actually negotiate with the resource manager for containers and will launch the containers on the machines. So whenever a container is launched, a new process called STRAM child will run on inside these containers. Again, STRAM child we'll see in details in coming slides, but I'll just briefly tell you this STRAM child is responsible for hosting your operators and buffer server. I hope you remember I introduced you to the operators. Operators are the logical units where your processing will happen. Your like business logic or whatever processing you want to do on the data will happen inside these operators. So the STRAM child is actually responsible for hosting these operators and managing lifecycle of these operators. So I hope this flow is clear. So by looking at these last two slides, um, we have this understanding like how the Yarn client, how a Yarn application is run in general, and how Apex is run, and what all the components it adds you to make this platform work. Again, I'll take 1 more minute break because I think we introduced a lot many new things, and if someone has new questions, I can take it right now.
So one question is, where are the Apex libraries located in the help cluster? How will the data node see those libraries?
Okay, so I'll tell you in briefly how does that happen in next slides. But Apex library is ultimately going to be a jar. Like your library obviously is a Java code, and when you compile it, you will get a jar, and that will be used when you actually run your applications on Java cluster, Hadoop cluster. Because I'll take this question because it goes with the in the next slides. Any other question, Yogi?
Does Apex supports only streaming, or does it have support for historical data as well?
We do support both streaming as well as batch processing. So actually, this is like we are on top of Yarn. So and Yarn allows everything like streaming, batch processing, and everything. So practically, we can also do batch processing. We actually have customers who do use Apex for batch processing as well, along with streaming.
So just to add to what Priyanka was mentioning, so let's say if you have 1 day's worth of data and you want to play the data now in the DAG, so on the input side, it could just read the data from any file system or from any store as such, or through a web service and just keep on playing the data. So it could be an old data. So the event date time would be different from the processing date time. So there could be two scenarios where the event date time is the same as the processing date time, which is like a more real-time scenario, or the other way around.
Okay, let's go ahead. So let's look into these components of Apex one by one. Okay, I think we have one more question.
One more question.
Yeah.
Saying to explain the first line of process from Apex CLI to Yarn client. How is the communication done?
Okay. That communication actually happens over client RM protocol, and actually Yarn has with respect to this protocol, Yarn has actually exposed few APIs. So what this Yarn client has to do, it has to call those APIs. This all communication happens over the remote procedure called RPC, and Hadoop handles all that. All you have to do is like you need to know like which all functions you need to call for resource manager and all. So and all that communication is handled over this client RM protocol. Okay, then I'll go ahead. Let's look into these components. First is Stamp client. So what is Stamp client? Strong client, I have it's a part of Apex command line interface. And how do you use it? Like to use Stamp client, you need to run this script called as Apex. So when you install DataTorrent, in the bin folder, you will find this script called Apex. You just need to run it, and you will get this command line Apex. Uh, when you want to run any application in your cluster, you just have to run this command launch and the application package file. Mm. So when you do that, what all things happen? Like what all things Stamp client does? This will also answer one of the questions which someone has asked, like where is your malware library when you run an application? So what this Stamp client does, it copies the required application package files to the HDFS. What does it mean? Let's say when you want to run an application, you have written your code and compiled and packaged as a jar, and also you have all the class path dependencies and configuration required to run this application. Now, as you want to run this application in a distributed cluster, you never know like on which node your process is going to run, and all these processes are going to need the access to your resources like the jar files, your class files, or whatever dependency files you have, or even the configuration you want to use. For that, to make it available to each and every process which is going to run in your cluster, we copy it to HDFS. HDFS is a distributed file system which is a part of Hadoop, and once you copy it there, any that data is accessible node in your cluster. Next thing it does is validates the logical plan. The logical plan is actually the DAG which we just saw, that it is made up of operators and streams. So to run your application or to create your application, you have to put these logical blocks or the processing blocks which are called as operators, and you need to connect them using streams. So there could be some some things which are not allowed, or the way you are supposed to do it is not, like you're doing it is not supported. So all that validation is done upfront to save the problem, like to those problems are we identify them beforehand, and then we report it as right there. Next thing is it serializes logical plan as such as well. So that DAG which you have explained is the actually plan. That plan is understood by Apex platform and executed by Apex platform. So to communicate that plan, which is a logical plan, is also serialized to the Hadoop file system. And the last thing is it contacts the application master and tells it provided all this information. Like it is given the application package, all the required dependencies, it has copied to HDFS, it has the plan to execute and everything. And now it contacts our resource manager. And then resource manager, as we expect, will launch the application master, which is a STRAM for Apex. So what STRAM does? Now STRAM is application master. Once the STRAM process comes up, what it will do, it will read this logical plan which has been serialized by client, STRAM client, and it will It will read this logical plan and convert into a physical plan. Now, what does that mean? So logical plan, actually in logical plan, you just say operator 1 is connected to operator 2 in a specific way. But then you might want to detail out when you run this application, please please launch the 4 instances of operator 2 because operator 2 is doing very heavy processing, and I want multiple instances of it to to move faster. So all those details will be worked out by Strum, and a physical plan will be created by the Strum. Again, this physical plan will be serialized by the Strum to the HDFS again, because we are going to need this information further, and that is going to be used by the containers. Again, that will come in next slides. Once it serializes all this data, it will start talking to the resource manager to allocate containers to actually carry out all the processing or to do all the processing. So when resource manager comes back with the available resources and launches the container for us, it runs a process in each and every yarn container, which is called a Strum child. After launching the Strum child, it constantly keeps in touch with the Strum child to know the health of Strum child. Also, it collects the statistics from Strum child to know the overall statistics of the application. It also hosts this statistics on a web service, so that you can you can connect to this web service at any time and know the application statistics. Then also it takes care of fault tolerance by checkpointing the data on regular basis. It also helps in configuring your security, serverless authentication, and everything. And it also takes care of shutting down the application when someone requests it from outside, or if there is any trigger to shut down the application. And let's see at the last component, which is like Strum child. So Strum child, we just saw that it will run inside each and every container. So what are the responsibilities of a Strum child? The Strum child is it has to host the operators and buffer server. Operators are actually logical units where processing will be done, and buffer servers are the pub sub queues which connect operators. So when, let's say, there are multiple operators connected to each other, so whenever one operator is done processing the data and it won't push it to the next operator which is sitting in some other container, the buffer server will host the data in meantime. Like it will act as a queue and will help you move the data from one operator to another operator. And all these are hosted by the containers and managed by the Strum child. So Strum child has to actually keep monitoring the operator health and has to keep communicating to the Strum the health of this particular operator or the container, which is done using heartbeat and also sending the regular information. It also is responsible for executing any command which comes from the Strum. It also helps in shutting down the application. It manages the life cycle of each and every operator running inside that particular container. And yeah, because it hosts the buffer server, it is responsible for communication as well. So I think after understanding all these major components, I'll just go back and see like how that application workflow is done using these components. So first thing, we use Apex CLI to launch an application. Then our application master, which is Strum, is launched. Then Strum will launch the Strum clients everywhere, that Strum child. And the Strum child will actually deserialize the physical plan which was written to HDFS. In this physical plan, there will be actually information how to run each and every operator, like what all to do inside each and every operator. So let's say operator 1 is just supposed to read data from some input source. Operator 2 is supposed to parse that data. Operator 3 is just supposed to add all the, let's say these are the data is actually numbers. So operator 3 maybe is just supposed to add all these numbers. So all that data information was part of physical DAG, which is deserialized by Strum child and is actually carried out inside the operator. That all that operations are carried out inside the operators. And again, stop for questions. Okay.
We don't have any major questions.
Okay. Okay. So I think I'll just summarize. Then we are almost at the end. Mm, so we have seen that yeah, like using how do we use Yarn to run our streaming platform. Like we use Yarn capabilities for scheduling and resource manager majorly to run our streaming platform, which is Apex. And then because of we take care of all these responsibilities of running an streaming application with help of Apex, you just have to concentrate on your business logic when you develop an application, and rest all is handled by Apex and Yarn together. Um, Questions?
So,
Yeah.
how is job failure is handled, and is there any speculative execution mechanism in Apex?
So job we take help from Yarn to do failure handling. So I'll just go back to a slide where we had this. Okay. Okay. No. So we have seen that here resource manager is responsible for checking health of each and every resource. Resource is a container actually. Health of each and every container in your cluster. So let's say any of your container goes down, the resource manager will know that, and a resource manager will then actually redeploy that container to some other node. So let's say your node 1 goes down and there was a container on that. So resource manager will actually reschedule it on some other machine. Let's say your application master itself goes down because it is also a container. On HDFS, and when it is redeployed somewhere else, it will read its checkpointer states and start running from there. So that fault tolerance is handled by Apex platform, and the Yarn helps in rescheduling that killed containers. So this is how we handle fault tolerance.
We lost your voice for last couple of minutes.
Slide where on top of the streaming platform we had a Malhar library, so it's open sourced, available on Apache. Basically, these are the operators which actually become part of the directed acyclic graph. So let's say if you want to read from a data store and throw it in the pipeline, then within the pipeline, if any query has to be done, then another operator so these are the two ways where a querying mechanism can be handled in Apex as such.
Okay, I think there are no more questions. If you have just missed out, and you can anytime send us questions. I'm going to share these slides. I have my email address also there, so you can answer your questions. We would be happy to help you. And here are a few of the resources like we do refer, and what are the Apex resources we have. So go ahead and join our community to listen to our discussions for use cases related discussions or technical discussions. We also regularly conduct physical meetups and webinars. So if some meetups are happening in city, we encourage you to go ahead and attend them. Then we also have examples we just had a question about SQL, right? So we have a lot many examples there to connect to different databases, different file systems, do different kind of and follow these links to know more. And we also have actually startup accelerator program. So if anyone of you want to try out DataTorrent products or Apex product with minimum support, we can actually provide sales team, and you'll know more about it.
Well, thank you everybody for today's session. As Priyanka mentioned, if there are more questions, you can always come to our forum, or the slides and the video for today's session will be available shortly. Thanks a lot for your time. Appreciate it.